In this first video, we're going to introduce a few of the tools, the main tools that we have for solving equations. So the first tool is known as our addition property of equality, or for short APE, APE. It allows us to tinker, or if you want, monkey around, because it's APE, with the equations. It allows us to move stuff from one side of an equation to another. And basically what it says is quite simply that if you have an equation, then A plus C, if you add the same thing, or you can subtract, we write it in terms of addition, but we could subtract. The image you want to have here is of a seesaw. If you're on a seesaw and both sides are balanced, you have the same weight on both sides of the seesaw, well then if you add the same weight, it's not going to change. Or another visualization would be to think of like scales, like the scales of justice. If you have the same weight on both sides, it's going to be balanced. If you then turn around and add or take something away from both sides, as long as it's the same amount, then it'll stay balanced. So to see how this works, let's consider an equation. X plus 5 equals 12. Now pretty much all of us, I'm sure, can look at this and realize that the answer has to be 7. But we want to develop tools that we can use so that we can apply that to more complicated problems. And here's where the addition property comes into play. We want that 5 to go away because we want to just have x equals. So towards that end, since that 5 is being added, to make it go away, I perform the opposite, which is to subtract 5. So that the 5 minus 5 completely cancels out, and we're left with just x. And then, of course, being an equation, because of our addition property up above here, right, we have to do the same thing to the other side as well. So we subtract 5 from the 12. At this point, upon simplifying, the 5's cancel out. Right, we have just x, and 12 minus 5 is just 7. And so we can use this addition property to move stuff from one side of the equation to the other. What we've essentially accomplished here is we took the 5 that was over there with the x and moved it over to the other side to combine it with the 12. And the process here was done by subtracting. Our second tool is the multiplication property of equality, or oompa. I always think of the little Oompa Loompas from Charlie and the Chocolate Factory when I think of this. So the addition property allows us to move stuff from one side to the other. The multiplication property allows us to do whatever it is those little Oompa Loompas do. And it says that if you have an equation and something that's not 0, then you can multiply or divide both sides of the equation by that number. Of course, multiplying by 0 would kill your equation. That's why it's left out. Dividing by 0 is something we can't do. Now, for our purposes, the kind of equations that we're going to be solving, we're not ever going to worry about this. But if you go further in algebra, that possibility of multiplying by 0 could come about. It happens when you multiply equations by variables instead of numbers. Then you have to be worried about that. But that's not something we have to worry about in this course. To see the multiplication property in action, consider the equation 3x equals 12. Now most of us can look at that and realize, hey, the answer is going to be 4. But again, we're looking to develop a pattern that will work for more complicated problems. And so since that 3, remember when a variable is next to a number, the operation's multiplication. So I do the opposite of multiplying by 3, which is to divide by 3. And I have to do that on both equations. And then we simplify. 3 divided by 3 completely goes away so that we have just x. And on the other side, we simplify. 12 divided by 3 is 4. And so we get the answer x equals 4. The final tool we have is one that you've seen before. We just used it in the previous sections, previous topics, where we're simplifying algebraic expressions. And that's the same use here. And that's our distributive property. Right? And recall that our distributive property simply says that if you have an addition next to a multiplication next to an addition or subtraction, then we can distribute through. Remember also that was the governing principle for us to be able to combine like terms. So we can use this distributive property to do both combine like terms and to multiply across an addition or subtraction problem. In future videos we're going to be looking at solving some equations now, and they're going to slowly get a little bit more complicated, but it's all based around these three properties.